Welcome back. My name is Kirsten McMillan with the Climate Risk Institute. In this course, you're learning about how to integrate climate change into the planning, design, and operations of water infrastructure. But in order to do this, we must first understand how climate can impact water infrastructure, including through the types of climate events that can damage components, and how these impacts can result in the failure or reduction of service of water infrastructure. At the most fundamental level, we all understand that water is life. Climate change has and will continue to significantly impact the world's access to water. Right now, 80% of the world experiences threats to water security, and this will only increase with climate change. There are significant concerns about how water infrastructure will respond to climate change. These headlines point to the increasing risk of failure. So more dams will collapse as aging infrastructure can't keep up with climate change. As large dams around the world age, operational costs and the risk of collapse increase while overall efficiencies decline. And expect more. Climate change raises the risk of dam failures. These three together demonstrate why it's so important to integrate climate into all stages of the water infrastructure life cycle. What is water infrastructure? This can mean many different things depending on your local context, organization, scale, or scope. You may be thinking the entire Nile River basin or down to an individual household. In this module, we will primarily be looking at hydraulic infrastructure like dams and irrigation. These have many different uses, including for hydropower or flood control, providing drinking water, or the canals that are required for irrigation and agriculture. Other aspects that may come to mind when you hear water infrastructure include drinking water or wastewater, and components like a pipes network or a wastewater treatment plant. These can also be significantly impacted by climate change. So why is it important to consider climate change and water infrastructure? First, water infrastructure has long lifespans. We cannot design with only the past conditions in mind if infrastructure will be unable to perform under future conditions. Second, it's more cost-effective. Money invested into climate-proofed infrastructure now will be much less expensive than responding to catastrophic events in the future. And finally, these are complex systems. We need to think about how different infrastructure components will work together and how the impacts of climate will be felt in different components. What are the types of pressures that water infrastructure systems face? We're primarily talking about climate stressors in this module. However, it's important to think about some of the non-climatic stressors as well. So, for example, how increased runoff due to land degradation or land use changes can impact water infrastructure, pollution impacting water quality, and things like changing demand and how this could put more pressures on the system. We can think about how some of these interact together. So, for example, extreme heat resulting in lower water levels, while also thinking about how urbanization or population growth may be putting additional strains onto systems. In the following slides, I'll walk through 4 examples of climate stressors and how these can impact water infrastructure systems. So these do not represent all of the impacts of climate change. However, these are a few examples to get you thinking about some of the potential impacts to dams and upstream and downstream areas. We'll be looking at high temperature, drought, heavy precipitation and high water levels, and wind. First, before the dam is even built, there can be climate impacts to the surrounding infrastructure, like access roads. High temperatures, or large variations between high and low temperatures, can result in expansion and contraction that leads to cracking. Over time, this type of damage can require more maintenance and costly repairs. It's important to remember that when you think of climate impacts, it's not just about extreme events, but also some of these long-term stresses and costs. High temperature can also be dangerous to construction, operation, and maintenance staff that help to keep these systems running. It can be very dangerous to work in extreme temperatures, and you'll often need to pause or stop work until it is safe to return. This can mean that services are down for longer or that construction schedules are slowed. There are also some materials, like concrete, that cannot be placed during extreme heat. Both of these are examples of thinking about the climate impact in your scheduling. The variability of temperature, like changing from high to low temperature, can result in the expansion and contraction of concrete and result in cracking and damage to structures. While there are many different ways to prevent this from happening, it's important to have a plan in place for variable temperatures during construction and repair. Let's talk about high temperatures and the electrical systems that would support water infrastructure. Increased temperature can cause damage or reduce the functionality of electrical equipment. If the electrical equipment needs to be shut down, so for example like these turbines if they were overheating or required repair, this would severely impact the ability to provide hydropower and water for irrigation or for drinking. There may also be requirements to use backup power sources like a diesel generator, which could be much more expensive. We can also think about transmission lines and how these can be damaged in extreme heat. They can also have their efficiency reduced over time. This is an example of a transmission line that would require quick repairs under a high temperature event, and thinking back to the impacts on the staff that would be required, how might a high temperature event limit the ability to get in and do the repairs that are necessary? High temperature and drought are often intersected impacts, and the combination of the two can have very large negative consequences. When a drought occurs after a long period of high temperature or limited precipitation, there can be widespread effects to water infrastructure. For example, impacts to the water quality and ecosystems. This can occur through decreasing oxygen content, increasing bacteria, or impacts to the breeding habitats of aquatic life. Lower flow levels can also result in more stagnant water. Thinking about all of these together, this could really impact water quality and the ability to supply clean drinking water. It could also damage some of the downstream equipment, particularly if the water becomes more corrosive. This photo shows an algae bloom. Algae blooms are expected to increase in many areas due to the combination of warmer temperatures and greater nutrient pollution, demonstrating how climatic and non-climatic factors can contribute to worsening water quality. Sustained periods of high temperature and little precipitation can increase the amount of evaporation, leading to overall losses in water. Depending on the dam's use, this can mean reduced capacity for energy generation, reduced water supply for downstream communities, and reduced storage availability. This photo shows the Hoover Dam in the United States in 2021, which experienced record low water levels during a drought last summer. These low water levels required emergency cuts to water supply for millions of people and significantly impacted agriculture and food security in the region. Many of the impacts from high temperature and from drought are interconnected. Beyond the impacts of drought on the dam itself, drought can have significant long-term damages to communities, such as the death of crops and vegetation, leading to food insecurity. Increased temperature or droughts could also change energy demand. It is therefore important to think about how an infrastructure system can respond to both increasing demand and lower flow conditions, and have flexibility in the way to operate, or else the impacts will be even more extreme. Moving on from these high temperature and drought conditions, let's discuss some of the impacts of heavy precipitation or high water levels. Although there are many different causes of flooding, and these can vary significantly depending on the region or the infrastructure type, including by things like extreme rainfall or increased stream flows upstream, we're going to discuss flooding as a whole and how this can impact water infrastructure. So, for example, before the dam is even constructed, it is important to think of the potential climate impacts and how flooding could impact the project. For example, low flow conditions may be required during construction. Consider the challenges in establishing something like a dam or access road if you were under flooding conditions like shown in this photo here. This could create very unsafe conditions and delay the ability to begin any construction. Transmission lines can fall due to floodwater or increasing groundwater that can weaken the soil. This is also a good example of how storm events that include rain and wind can combine and have more damaging impacts. You can see here in this transmission main there's some flooding on the water below, and they also could have been knocked over from wind during a storm event. In an emergency, these fallen lines can be very dangerous for the public. It can also be very challenging for emergency responders to access and perform repairs, especially if things like an access road is limited. Even if the dam itself may not fail due to an extreme event, we have to think about other services like electricity and water and how these would not be supplied to the community. Other examples of impacts of heavy winds are increasing loading on structures such as dams and buildings. With wind, we can also think about increased wave heights in the reservoir and how this would require greater freeboard. Continuing with the examples of high water levels or rain events, flooding can restrict access and damage roadways. This can limit access in extreme events, flood conditions can damage electrical systems directly, like flooding the powerhouse. The system may not have been designed for high flows and could be above the capacity of turbines and other electrical equipment. High water levels can also have more sedimentation, which can damage equipment like turbines. You can see in this photo the example of the high amount of sedimentation and how this would subsequently damage some of the downstream components like turbines or engines or anything that would handle the water. It could also really impact the water quality with that amount of sedimentation. In high flow events, culverts and drainage infrastructure can also become overcapacity, resulting in additional flooding. And although spillways are designed to accommodate very high flows, these can still be overcapacity in extreme events. An overcapacity spillway can have some of the most damaging impacts to water infrastructure, as the dam is no longer able to pass flows safely and could result in the complete failure and significant flooding and damage to downstream communities. Unfortunately, there are many examples of catastrophic flooding incidents when dam spillways fail. In recent years, the Oroville Dam in California is one example of what can happen when a spillway fails. This dam was designed with two spillways, a service spillway and an emergency spillway. When the service spillways failed, this subsequently led to high water levels and the emergency spillway being overtopped for the first time in history. In this event, the maximum flow was much lower than the original design capacity. However, there were significant concerns about erosion and the potential failure of a weir structure that could have resulted in uncontrolled flooding. This event resulted in the evacuation of 200,000 residents and an economic damage of $1.1 billion. Although this event is not attributed directly to climate change, it serves as an example of both the potential impacts from these large storm events and a cautionary tale to take a proactive approach to risk management. Here's an additional photo of this failure, and please refer to the case study linked in the course resources if you'd like to know more about this. Continuing on, flooding and high water levels can increase the risk of slope instability, where erosion can lead to the failure of dam walls. This is an example from the Kunagawa Levee in Jozo, Japan. This is a 3.6 meter earth-filled dam, and after a period of extreme rainfall due to two tropical cyclones, the river rose 10 meters over a 24-hour period. The levee breached into a residential neighborhood, and the backside of the levee eroded very quickly after being overtopped. Unfortunately, there were 2 fatalities, and it required the evacuation of a complete residential neighborhood. And you can see the level of destruction from this flooding event and how the dam infrastructure could be severely impacted. Finally, when we're considering climate impacts, it's important to recognize the complexity of compounding events. We've already discussed some of the combinations like drought and high temperatures and extreme precipitation and wind, but there are a few other examples of the fluctuation between these conditions. So for example, periods of drought followed by flooding. This can result in the cracking of dam infrastructure, particularly for earthen dams. When this cracking occurs, dams can seep water or fail completely. You could also think about a multi-year drought or something like a forest fire where there's increased amounts of sedimentation. This sedimentation reduces the storage capacity of the dam, and then if you had a large storm event, there would be more flooding because there was not enough capacity in the reservoir. So the combination of these two events together demonstrates how it's very complicated to think and plan ahead for these compounding events, but is a necessary part of climate proofing. I hope this has been useful to walk through some of the examples of the climate impacts on water infrastructures. Thank you.